Hi everyone. In these videos we're going to be talking about Chapter 12. And as most of you know, Chapter 12 is a really long chapter. I think I might have 4 or 5 videos that go along with this chapter. So first let's just talk about the definition of a probability. The probability of an event is the proportion of times that the event occurs in the long run. So for example, if we're flipping a coin, if I flip it just once, I can't predict the outcome of that one flip. I can make a guess, but I can't make a prediction. But if we flip that coin many, many, many times, I know that half of the time I'll get heads and about half of the time I'll get tails. And therefore, we say that the probability of flipping a head is 1/2 and flipping tails is 1/2. This is called the law of large numbers. So it says that as a probability experiment is repeated over and over again, the proportion of times that a given event occurs will approach its probability. And I have a graph here of flipping a coin and seeing what happens. And you can see that in the beginning, there's a lot of variation between the proportion of heads to tails. But as it goes out to thousands and thousands and thousands, we get something very, very close to 1/2. So just looking at the basics of setting up probabilities, the first thing that we want to talk about is figuring out the sample space for an event. So I've got these 3 examples here, and we're going to follow these 3 examples for a couple of slides here. So the first example is tossing 2 coins. What is the sample space for tossing 2 coins? This would be all of the possible outcomes that can happen when you toss 2 coins. So we could get heads with the first coin and heads with the second coin, tails with both coins, heads with the first and tails with the second, tails with the first and heads with the second. And notice that those last 2 possible outcomes, they are considered different possible outcomes. The sample space for rolling a die. When we roll a die, we can get a 1, 2, 3, 4, 5, or 6. So that is the sample space. If we have another example where it's a selection of a student at random from a list of 10,000 at a large university, the sample space would be that list of 10,000 students. So when we talk about possible outcomes for a sample space, we call those events. So we could have the event of observing 2 heads when flipping 2 coins, and that would look like that. Or we could say the event is rolling an odd number when we're rolling a die, and that would look like the collection 1, 3, 5. Or an event could be observing a student with a GPA of higher than 3.5, and this references back to that list of 10,000 students at a large university. So then the event would be all of the students whose GPA is higher than 3.5. So when we're calculating a probability, we use probability notation. And I know that there are some students that really hate this notation. But basically, when we put a capital P and parentheses around the event, we are talking about the calculation of the probability of that event. So if we're looking at the probability of observing 2 heads, we would write a P with parentheses around HH, for example, as an abbreviation. Or the probability of rolling an odd number, maybe we write out the words odd number, maybe we make a list 1 through 5. And then probability of observing a student with a GPA greater than 3.5 would look like this. So then when we're calculating a probability, and again, not again because I didn't actually say this, but when I'm calculating the probability of equally likely events, this part is important right here. And we'll get into what happens if they're not equally likely. But the probability of equally likely outcomes or equally likely events means that we're going to take the number of outcomes from the event and divide by the total number of outcomes in the sample space. So if we're calculating the probability of observing 2 heads, remember that the sample space for flipping 2 coins had 4 outcomes in it. So we would have the 1 out of 4 chance of getting 2 heads. The probability of rolling an odd number, well, we have 3 odd numbers out of a total of 6. And so we would have 3 out of 6, and we could reduce that to 1/2. With regards to calculating the probability of a GPA greater than 3.5, we would have to take the number of students with a GPA greater than 3.5 and divide by the total number of students. So we have some basic probability rules. First is that any probability will be between 0 and 1. A probability of 0 means that the event can never occur, and a probability of 1 would mean that the event always occurs. But please remember that any calculated probability will always be between 0 and 1. You're never going to have a negative probability, and you're never going to have a probability greater than 1. Let's look at the next example. So we have, there are 10,000 families in a certain town that are categorized as follows. So we have families that own a house, own a condo, rent a house, or rent an apartment. And it says a pollster samples a single family from this population. What is the probability that the sampled family owns a house? Well, looking at the calculation here, we have 4,000. Actually, let me write the probability notation here. So the probability, I hate it when it changes colors on me. No. All right, probability that they own a house is going to be this 4,753 out of the total 10,000 families. And this will give me a probability of 0.4753. We can round that, or we can just leave it the way it is. What is the probability that a sampled family rents? Well, now there's 2 ways that we can observe a family that's renting. They can either be renting a house or renting an apartment. So the probability that a family rents would be the probability that they are renting a house plus all of those who are renting an apartment divided by this 10,000. And for that, I have all my calculations in a notebook here. We have 3769 out of 10,000, giving us 0.3769. So just one more topic in this first introductory video, which is just talking about how we define unusual events. And this is actually going to lead you into Unit 3. An unusual event is one that is not likely to happen. And in statistics, we usually consider this an event that has a probability that is less than 0.05 or less than 5%. So for example, in this one it says in a college of 5,000 students, 150 are math majors. A student is selected at random and turns out to be a math major. Is this unusual? Well, the probability of observing a student that's a math major would be 150 out of 5,000. And this is 0.03. Since this is less than that 0.05, we would say yes, this is unusual.